Hey guys, today we're going to cover constant of proportionality. So this one is a little bit different from what we've been doing. Something that you need to know about constant of proportionality is that it involves a proportional relationship. Everything that we've been doing so far has been non-proportional, meaning that it does not go through the origin. When we graph it, for example, it doesn't have that coordinate 0, 0. But today, everything that we're going to be doing will go through the origin. And basically, the slope, what we calculate today, is going to represent what's called the constant of proportionality. You guys are familiar with this as well because I know in science you've been working on speed with distance over time. So that is proportional. And yeah, so let's go ahead and get started. Up at the top here it says Liam is making breakfast for dinner using a pancake mix. Part A, how many cups of mix will he use for 12 pancakes? So let's take a look at the table. I'm going to look and see where it says number of pancakes 12. And then to the left of that it says cups of mix 1. So I'm going to put a 1. Then it says how many cups of mix will he use for 24 pancakes? Well, it says 2. And then C says what is the ratio of cups of mix to servings? So it's important that you write it in the order that it's stated. So cups of mix, well, they had 1, and then the serving was 12. And then the other ratio is 2 to 24. But if we simplify that, I could divide both these numbers by 2, and I would get 1 to 12. So that ratio simplifies each and every time 1 to 12. So let's talk about proportional relationships. A relationship is proportional when the ratio of y over x is constant. Oops. And then now we're specifically going to talk about constant of proportionality. So the constant of proportionality is the value of a ratio of two proportional quantities. So it is represented by the equation k equals y over x. So this one is, the mathematician that invented this was German, and a lot of times in the German language they use k when we use c, so that's where the k comes from. All right, y represents your dependent variable. Y'all already know that though, so this is nothing new. So this is your dependent variable. And then x represents your independent variable. And then the equation is y equals kx. So we use that to represent proportional relationships. All right, it says for 1 through 3, find the ratio of y over x to determine if each table represents a proportional relationship. Well, we're not going to do 2, so you can put an x through that. But we are going to do 1 and 3. All right, so we have to use this ratio of y over x, which we've been essentially doing that this whole time in this unit. So again, nothing really new. So if we look at our first ordered pair, it is 1, 6, but we have to set it up as 6 over 1, which simplifies to 6. And then this next ordered pair is 2, 12, but we are going to set it up as 12 over 2, which if we divide that, it simplifies to 6. The next one is 18 over 3. which simplifies to 6. And then this last one, the ordered pair is 4 and 24, but we have to write it as y over x, or 24 over 4, which again simplifies to 6. So it is safe to say that this relationship is proportional, because when you do the ratio of y over x, it simplifies to 6 and it equals 6. The difference between what we've been doing now, or what we have been doing and what we're doing now, is that we don't necessarily have to look for our change in y values and our change in x values. In order to figure out whether it's proportional, you just set up the ratio of y over x and you would just divide. Okay, we're going to skip over to number 3. So our ordered pair is 8, 4. And again, we need that ratio to be y over x, so it's going to be 4 over 8. And that would simplify. I could divide both numbers by 4, and it simplifies to 1/2. The next one is ordered pair is 10, 5, but we have to write it as 5 over 10 because it's y over x. And that simplifies to 1/2. The next ordered pair is 12, 6. Again, we have to write it as 6 over 12, which simplifies to 1/2. And then this last one is ordered pair is 14 and 7, and that that ratio is 7 over 14, which I could divide both those numbers by 7, and it was simplified to 1/2. So it's safe to say that k, the constant of proportionality in this problem, is 1/2. If those ratios divide to the same number, then it's proportional. All right, we're not going to do 4, but we are going to skip over to 5. All right, it says a car travels 220 miles in 4 hours. What is the constant of proportionality that relates y, the total number of miles, to x, the number of hours? Well, we know to calculate the constant of proportionality, it's k equals y over x. So then I'm going to go back, and if you notice, I underlined them in different colors, and it's because it says y is the total number of miles. So I'm going to put miles on top, and then x is the number of hours, so it's miles over hours. And then I'm going to go back and plug those numbers in, and I see that I have 220 miles, so 220 goes on top. And then 4 hours, so 4 goes on the bottom. So then I would do 220 divided by 4, and that would give me 55. So k, the constant of proportionality, is 55. All right, flip your paper over. Now we're going to look at tables and graphs. All right, it says to use, in number 6, use the graph below to complete the table and answer the following questions. So let's take some coordinates from this table. If we look at this first one right here, this one right here, it's right at the origin, and the coordinate for the origin is 0, 0. Like I said, in proportional relationships, it's going to go through the origin. If it's non-proportional, it will cross the y-axis somewhere else, which is what we've been doing prior to now. Okay, another coordinate I notice is 1 and 10, because remember, you read your x values first. X values are the ones that are left and right, and then y values are the ones that are up and down. Another coordinate I see here is 2 and 20. Oops, 20. And then another coordinate I see is 3 and 30. All right, we filled out the table. So let's go ahead and take a look at the constant of proportionality. So they want us to find k, which, remember, k equals y over x. So we're going to pick a coordinate and we're going to divide. So the first one that I see is 10 over 1, which equals 10. We could do another coordinate if we want to. We could do 20 over 2, which if we divide that, it's 10. So it's increasing by 10 each and every time. So the constant of proportionality is 10. Part B, it says, what does the point 1, 10 represent in the relationship? So going back to this, 1 represents our x value, which is number of tickets. And then the y values represent total cost. So now we're going to use some words here. So 1 is for tickets, number of tickets, and then 10 is the total cost. So it's safe to say that 1 ticket costs $10. And that's true because if you buy 2 tickets, it's $20. 3 tickets, $30. 4 tickets, $40. So on and so forth. All right, let's take a look at number 7. It says use the graph below to complete the table and answer the following questions. So again, we need to pick some coordinates. I'm going to start with this one right here in the corner, which is 0, 0. And then I'm just going to keep going and look for those where the line crosses at those intersections. So remember, x values are the ones that go left and right, and y values are the ones that go up and down. So my next ordered pair is 1, 3. And then my next one is 2 and 6. So 2, 6. And then 3 and 9. And that's it for the table. So now we have to find our constant of proportionality, or k. K equals y over x. So let's kind of zoom in a little bit at this table. We're going to set up our ratios. So the first one would be 3 over 1, which equals 3 if we were to divide. Another ratio is 6 over 2, which if we divide, that would equal 3. And then our last ratio would be 9 over 3, which if we divide, it's 3. So it's safe to say that our constant of proportionality is 3. All right, part B. What does the point 1, 3 represent in the relationship? So I'm going to go back and highlight. So remember, x values represent hours, and then y values represent miles walked. So the 1 is the number of hours, and the 3 is the miles walked. So we could draw a conclusion saying a person walks 3 miles in 1 hour. And remember, if I'm going too fast, you can always pause the video. Okay, let's take a look at number 8. It says to use your understanding of constant proportionality to answer the questions below. Number 8. While training for a marathon, Keith's watch reported the number of calories he had burned at each mile marker. The data is shown below. Now this table is horizontal, so don't forget your x values are the ones that are on top, and then your y values are the ones that are on the bottom. And when we find our constant of proportionality, we're going to have to set this up opposite. Remember, it's y over x. So part A is the number of calories proportional to the number of miles. Justify your thinking. Well, you would have to set up all these ratios of 117 over 1, which equals 117, obviously. And then you would do another one of 234 over 2, which does simplify to 117. And if you keep going, you would see that they all divide into 117. So is it proportional? Yes. Why? Well, all ratios simplify to the same number. So they all simplify to 117. Okay, part B. It says, what is the constant of proportionality that relates y, the number of calories burned, to x, the number of miles? So k equals y over x, which equals, notice I underline stuff, so the y represents calories, And then X represents miles. So it's calories per miles. And again, we know that it is 117 over 1, which equals 117. Part C, it says to write an equation to represent the relationship between the number of miles and calories burnt. Now, back on the front side of the page, we wrote it briefly. The equation is y equals kx. Well, we just solved for k back in part B, and so all we have to do is just plug it in, because remember, the y in the equation represents our y values, and the x represents our x values. So the final equation is just y equals 117x. Part D. The next day, Keith ran 7 miles. How many calories did he burn? So we have to actually use our equation now. Remember, it is y equals 117x. X represents the number of miles. So now we're going to write y equals 117, and then in parentheses, we're going to put 7. So this tells me that we need to multiply. So we're going to do 117 times 7. 7 times 7 is 49. So I have 9, carry my 4. 7 times 1 is 7, plus 4 is 11. So I'm going to put a 1 and then carry that other one. 7 times 1 is 7, plus 1 is 8. So he burned 819 calories. And I'm going to abbreviate that because I ran out of space. 819 calories. And then the last one, part F. If Keith's watch reported that he burned 1,170 calories, how many miles did Keith run that day? So again, we're going to use our equation. Y equals 117x. And the y represents the number of calories burnt. So I'm going to put 1,170 equals 117x. Now I need to isolate the variable, so I'm going to divide both sides by 117. So those will zero out, and you get 10. So he ran 10 miles. All right, good job solving problems related to constant of proportionality.